Hi everyone. We're going through more exam questions. I've just gone through question 2. The correct answer for question 2 was A. Question 3, we're about to go through the answer to now. So, what effect would reducing the pressure have? So remember that pressure is directly related to volume and number of moles of gas. So what will happen in both of these reactions is if we reduce the pressure, the equilibrium will favor the side, the reactants or the products, that has the most number of gas molecules. In both of these, that is the reactants. So if we reduce the pressure, we will drive the reaction towards the reactant, which is not what we want. We're trying to produce things here. If we increase the reaction temperature of an exothermic reaction, we will favor the reactants. Increasing the volume is exactly the same as dropping the pressure. And technically the concentration. So it's going to have the same effect as A. It's going to go towards the side with the most gas moles. Removing product, regardless of the equilibrium expression that you can see, will always create more product, or it will shift the equilibrium to the right. So the correct answer there is D. So question 4, sticking with the equilibrium. So remember your equilibrium, I'll give you a hint, it's products over reactants. That's all I'll say. Okay. 5 seconds. Everybody is going to go, hey, the answer is D. Anybody want to say why it's not D, or C, or B, or why it will be A? In an equilibrium expression, we only put the gas molecules. We don't include solids or liquids. So products over reactants, which is A, excluding iron and iron oxide on the left. All right, conjugate acids. I'm going to do the real maths and type questions next week. We'll probably do an hour and a half. I'm feeling nice next week. So conjugate acids, remember what constitutes an acid? So the conjugate acid is the original molecule SO4 2 minus plus 1 hydrogen. SO4 2 minus is the conjugate base of HSO4 minus. And it's not 2 minus because the hydrogen is a H plus. So it will reduce the or increase the overall charge by 1, or from -2 to -1. Okay, titration curves. So titration curves, 60 seconds. Okay, so we titrate a strong acid and a strong base. So the burette is underneath. And you're dripping into, it started at pH 1. The acid is going to be the starting point. So the acid was placed in the burette and the pH point equivalent at pH 7. So question 9, which pair of solutions would not produce that kind of titration curve? And this is where you need to think of what's a strong acid, what's a weak base, and vice versa. Sorry, the question asks actually, which of these would be most likely to produce the titration curve? So citric acid is not a strong base, a strong acid, but sodium hydroxide is a strong base. When you add a weak acid to a strong base, or a strong base to a weak acid, you get an S curve. Ammonia is not a strong base. It's a very, very weak base. So hydrochloric acid and sodium hydroxide, when they hit the equivalence point, you've got equal amounts of acid, equal amount of base, you will have a pH of 7, because when we add acids and bases together, we get the production of water. All right, question 10, again, 60 seconds. I want you guys to try and challenge yourself and get these answered within 60 seconds from now. So for this question, you would need to be thinking of the oxidation states. So Mg is magnesium in its elemental state. It has a little oxidation state of 0. Magnesium, when it's mixed with 2 chlorine atoms, which both have a charge of -1, would have a charge of +2 on the right-hand side. If you remember from my ranting about redox reactions, you'll remember that oxidation is loss of electrons, or the charge gets more positive. So we've gone from 0 to +2. Magnesium has been oxidized. All right, similar thing, question 11. Okay, so chromium is a transition metal. So we don't know its oxidation state until we calculate what it's attached to. Oxygen has an oxidation state of -2, and there's 7 of them. So that's -14. Chromium, there's 2 of them. But we have to leave a 2 negative charge on the overall molecule. So if chromium had 2 + 6 molecules in this compound, that would give us an overall charge on the molecule of -2. So I'm going to give 2 minutes for this one, starting from now. Remember, your isomers are your same molecular formula, different arrangement in space. I'm just going to grab a tissue. Time. So 60 seconds left. How many different ways can you draw that molecule? So you should be able to draw 4. So you got 2 carbons. You should be able to draw 4 different arrangements of the isomers. All right, question 13. We're getting to our naming our compounds. So again, 60 seconds. So we've got a chlorine, we've got 2, 3 chlorine molecules, 1, 2, and 3, 2 of them on the same carbon. So it's not going to be 1, or A, sorry. And it's not going to be D, because there's no methyl group. Do we remember when we're naming organic compounds, we have to give all of the parts of the organic compound the lowest number possible. So is it going to be 244 or 113? It's going to be 113 trichloro 2 fluorobutane. Okay, question 14. Now we're into boiling points. So when you're doing these, go through your head. Okay, what's the boiling point mean? What determines the boiling point? So 60 seconds, have a think about that. Okay, so it's nothing to do with the molecular weight because we're looking at 2 different classes of compounds. Carboxylic acids do not form dispersion forces. Well, they do, but they're not strong. There's no ionic bonds between the carboxylic acids. And carboxylic acids have stronger hydrogen bonding. They also have 2 hydrogen binding sites, which can provide them with what we call the dimer. So that also increases their boiling. Okay, so now thinking back to how could we determine if we had an alkene versus an alkane? Think back to that when we went through that. Okay, so when we add bromine to an alkane, nothing happens. Unless it's in the presence of UV light, and then it becomes a haloalkane. If we add bromine to an alkene, it gives us a dihaloalkane, which is colorless. So 2-heptene would be the most right answer in that case. All right, question 16. Esterification. Again, 60 seconds. Okay, so it's not going to be the first one because that's an alcohol. It's not going to be D because that looks like an alcohol as well, maybe a ketone and aldehyde. It's not going to be C because that's a soap. If you look at answer B, you've got cooch. So cooch tells us it's an ester. If it was coo, it would be a carboxylic acid. You can see that here. Okay, question 17. Powerful oxidizing agent. What happens when we oxidize a secondary alcohol? Again, 60 seconds. Okay. I'm trying to, we're probably not giving you the full 60 seconds now. So we oxidize, as in we kick the hydrogen off and we create a double bond. That would give us a ketone, and it cannot be oxidized any further than that. We know it's a ketone because you're going to get oxygen on double bonded here. It's attached to 2 carbons, so it's a ketone. Okay. So thinking from that question that we just did, if we are oxidizing a primary alcohol, we produce an aldehyde. If we then oxidize the aldehyde again, what are we likely to end up with? So 60 seconds. So if we oxidize our aldehyde, we would end up with a carboxylic acid. Because we're oxidizing the primary alcohol, kicking the hydrogen off, making a double bond. We oxidize the aldehyde, we kick the hydrogen off the end, we add our double bond with hydrogen on the end. So we have two. Okay, getting through quite a few of these. So monosaccharides are organic molecules that contain which of the following groups? Okay, so monosaccharides are either aldoses or ketoses. That should give you an indication of the two kinds of groups that are present on either of them. Ketose being a ketone, being a molecule covered in ketones, aldose being a molecule covered in aldehydes. So which of these would be considered a secondary alcohol? My voice is shredded from yelling at grade 9s. They don't like to listen. Okay, so secondary alcohol is an alcohol that the carbon that it's attached to is directly attached to two other carbons. So A is 3. So I found a mistake in this. Could technically be B or C. It's not going to be D because of the attached to 3. Okay, let's try and find one more question. All right, well, I think we'll finish on this because my voice is dead. So question 25. Okay. So it's not going to be methane, which is CH4. It's not going to be ethane, which is C2H6. It's going to be C. If I'm not mistaken, that would be what we currently make our soft plastics out of. All right, my voice is gone. Doing 40 hours of tutoring a week, yelling at my students all day is taking quite a toll. So I'm probably going to make this into like 15 or so recordings by the end of the holidays, and I'll put it into sequence, and you guys can sort of work through from the beginning to end. I will see you guys next week. We'll probably tackle a few of the bigger, like the 12 mark questions, and then work our way backwards through the short answer questions as well over the next few weeks. I will see you guys then. Have a fantastic week. Thank you for listening.